Now, we defined a function to be something that takes input values and associates them to output values. So we need to talk a little bit about the sets that are involved in that. Essentially, the set of possible input values is called your domain, and your set of possible output values is called your range. So everything that you can put into your function is in the domain, and everything you could possibly get out of your function is in the range. Now, range is usually a little bit harder to find, so for the most part we won't be messing with that just yet. We'll get to it later on in the course. For now, let's take a look at domain. So suppose you've got a function like f of x equals square root of x minus 5. Now, you realize there's some places that function's not going to be able to be evaluated. For example, if I plug in x equals 0, what I've got is a square root of negative 5. It's not going to give me a real answer, right? So I don't want that number to be in my domain. So what is it that needs to be true? I need to not have a negative under the square root, right? So to evaluate f of x, what I need is for x minus 5 to be greater than or equal to 0. That is, x is greater than or equal to 5. So this is going to be my domain. And if you restate that in interval notation, that says your domain is going to go from 5 to infinity. Alright, so in general, what are we looking for? So far, we've really only got two restrictions. First one's going to be no negatives under a square root. And actually it's an even root would be fine. So no negatives under a square root, a fourth root, a sixth root, etc. And secondly, no zeros in the denominator. Now any cross of these two things is fine. If you have a negative in the denominator, that's no big deal. If you have a 0 under the square root, that's perfectly fine. Square root of 0 is 0. So given that, let's see if we can piece together some domains of some more complicated functions. Suppose f of x looks like 1 over the square root of x minus 2. So what things do we need to be true? We need x minus 2 to be greater than or equal to 0 because of the radical. And we need x minus 2 to not be equal to 0, and that's because it's in the denominator. So between these two, that just says that x needs to be greater than 2, and so our domain is going to be from 2 to infinity with the parentheses on the 2. Remember, you don't want 2 included in this because if I plug in 2, I'm dividing by 0. Alright, another one. Let's say I've got f of x is 1 over x plus 2 minus 1 over x minus 5 plus the square root of, let's say, 10 minus x. Okay, so what do we need to be true? Alright, we need x plus 2 to not be 0, so that means x can't be negative 2. We need x minus 5 to not be 0, so that says x can't be 5. And we need 10 minus x to be greater than or equal to 0. That's going to tell me that x is less than or equal to 10, right? Because I'll have 10 greater than or equal to x, and then you can just reverse the whole thing. Alright, so I need all three of these restrictions to be happening at the same time. So it may help to write it out on the number line. Draw yourself a picture here. What's the numbers we care about? We've got negative 2. Here's a 0 for reference. There's a 5, and there's a 10. Now we know we're supposed to be not equal to negative 2 and not equal to 5, and we've got to be less than or equal to 10. So what we've got looks like this. Here's an interval, here's another interval, and here's another interval. And then it goes off to infinity on that side. So can you see where we've got three separate pieces? We've got a part that goes from negative infinity to negative 2, another one that picks up at -2 and goes to 5, and another one that picks up at 5 and goes up to 10. So our answer for the domain of this one is going to be -infinity to -2 with parentheses on the 2. You've got to have -2 to 5, that middle interval, and then you've got between 5 and 10. Now, what's the thing that we use to connect those pieces up? We want to be in here, or in here, or in here, right? We can't be in anything at the same time because these don't overlap, so we want to be in the union. That's what this big U symbol is. So there's your domain for that one. So if you have a more complicated function, the domain's not that bad. You just get the domains for the individual pieces, and then make sure you're in all of them at the same time.